Oh. Hello, welcome everyone. I guess we're going to get started. I am Jacob Tabak. I work at Timehop. Timehop is based here in New York City. We are kind of just a company that has an app, and our goal is to help you kind of relive your best memories with your friends, and it's a pretty great app. So anyway, last year, Google really blew away everybody's minds at I/O with all the new stuff that they released. Material design, Lollipop, just tons and tons of features. So this year, going into it, my expectations were set a little bit lower. I was definitely not expecting a repeat show. But still, there were some pretty great things that came out of the conference. We had the design support library, like the new permissions model, which is going to be really great. And then, of course, my personal favorite, and why we're all here, data binding. So just a quick show of hands. How many of you out here have had a chance to play around with the new data binding framework yet? Nice, not too many, cool. How about anybody who's used data binding in like WPF or Flex or any of those other frameworks? Nice. So, well, after they announced it, Timehop kind of were really early adopters when it comes to a lot of things. So we started playing around and experimenting with it. And now we have data binding built into our app in certain parts of it. And we found that it's really great for some things, and other parts, you may want to stick to traditional models, but basically I want to come here and talk to you today about the great things that data binding does, some of its shortcomings, and then help you decide whether or not it's a good thing for you to use in your app. So start with a definition, of course. Data binding, it establishes a connection between your app's UI and its data models. So there's two traditional types of data binding that we've seen in the past. The first one is one-way binding, in which basically you take your template, which is your XML layout, and then your data model, and then there's a one-time merge performed, and then automatically the data model is bound to the template, and it creates a view that represents your application's user interface. A more complex type of data binding is two-way data binding, in which case your model becomes the single source of truth for your UI. So as you can see in this diagram, the model is kind of feeding into the view, and then also the view feeds back into the model. So for example, if you had a checkbox or an edit text in your user interface, you could use those to update your data model in real time. And the advantage here is that you don't have to maintain state between your application and your UI. There's just one single source of truth. Unfortunately, two-way data binding can get a little bit tricky because sometimes you run into chicken or egg situations. Like what if user interface element is modifying the model at the same time the model's updating the UI? So you just got to watch out for those types of scenarios. Android's data binding approach is kind of like somewhere in between one-way and two-way data binding. You can have your model update the UI in real time, but there isn't built-in support for having the UI update the model automatically. But you definitely have the tools at your disposal to implement it fully if you want to. So just a quick overview of why you might want to use data binding in Android. First of all, it removes like almost all of your user interface code from your activities and fragments. So as we all know, activities and fragments are inherited from the platform. And those classes, if you've looked at them, they have thousands and thousands of lines of complex code. So generally, my philosophy is that your activities and fragments should really only be used to manage the life cycle of your application. So your UI code does not belong there, and data binding gives you a great way to get it out. Secondly, it makes your XML layouts become the single source of truth for your user interface. So in a traditional development model, you're going to have your layout file opened up side by side with your activity or fragment, and you have to cross-reference between them to determine which data from the model is being populated into which fields on the UI. So it can be kind of cumbersome to keep that straightened out. Another cool thing about data binding is it really eliminates the need to define IDs for your views. Data-bound fields, they're actually accessible directly from the binding, so you'll never need to call findViewById again. And as a related extension, findViewById is actually pretty bad for performance, as you may have heard. You often hear about the view holder model, which saves you from calling findViewById multiple times. Data binding actually has some internal optimizations that further improve that. So in a traditional activity, when you call findViewById for 5 IDs, that's actually 5 expensive calls. Data binding only has to do one traversal for the entire layout, and you can get as many views as you want, and they're all cached. So let's just take a quick look at the old way that you used to make an activity before you use data binding. This very simple layout is just a linear layout with 2 text views in it. And here's an activity that would power the UI for that. Basically, it's setting the first name and the last name text views to match this employee data model. So what's the problem here? Well, first of all, we have to define these user IDs. And this is kind of an annoyance of mine, but if you have multiple views with the same IDs in different layout files and you're refactoring later on, you're going to rename them all at the same time. So I end up coming up with these ridiculously verbose IDs, like activity main first name text view. Just make sure that I never have a duplicate. So that's annoying. Another problem is you have to do this senseless casting in find view by ID. So I mean, everybody hates it, and there's so many different workarounds like Butterknife and other open source libraries to get around it, but it's boilerplate, it's ugly, and it's terrible, and we don't want to do it anymore. Lastly, in this traditional data model, what I'm doing is essentially binding this employee object to my user interface. The employee has a first name and a last name. So why would I have to make two separate calls to set the first name and the last name text views? It should be an atomic operation. I'm binding an employee to the user interface, not a first name and a last name to the user interface. So here's an example of the exact same user interface, except this time using data binding. And this syntax may look a little different too if you haven't used it before, but I'll explain it later. So here, let's just notice the difference. Now, first of all, we have no IDs in the views. Secondly, we're definitely not doing any casting, and we're passing in that employee as an atomic method rather than individually the first name and last name. And lastly, we can reference the properties from our employee model directly in the XML file. So looking at this layout, you can see very clearly that the first text view is for the first name and the second is for the last name because it references those properties right there. So what's the motivation for data mining? Well, the motivation that I'm going to stress as the most important one is that it eliminates boilerplate. So boilerplate is a huge problem. It makes you write more code, leads to more development time, causes more bugs, and it makes your code harder to read. So boilerplate is evil. How did we get by before data binding? Well, open source to the rescue. There are tons of open source solutions for eliminating boilerplate. I just want to go over a few of them real quickly, and then we'll talk about how data mining has taken some of their best features and merged them together into something that requires even less boilerplate. So the first one, and my favorite, that I've used forever and ever and ever, and I wholeheartedly recommend to everybody, is Butterknife by Jake Warden. So the basic idea here is that you inflate your view, and then after you do that, you call this static method on Butterknife to bind your views. And once you do that, any view that matches an ID that you've declared in your bind annotation gets automatically mapped to that field. So you no longer need find view by ID, and you no longer need casting. Butterknife also has some other convenience methods, like you can annotate a method with the on-click annotation, and then instead of declaring an anonymous inner class for a click listener, you can just write a method, which makes a lot more sense. So as I said, I wholeheartedly recommend Butterknife, and I don't think you should stop using it if you love it. In fact, at Timehop, we use both Butterknife and data binding, but there's different places where both tools are appropriate. So second guy I want to talk about is this library I used to really love and embrace and advocate for wholeheartedly. It's called Android Annotations. It's actually by PY, who's also at Square. But he's long since actually donated the project to somebody else for maintaining, so I don't think he's used it for quite some time. But basically, Android Annotations had the mission to eliminate boilerplate at all costs. And some of those costs were high, some were low, but let me just show you quickly what it does. So instead of calling like butterknife.bind, you would instead annotate your method with this e-fragment, or sorry, annotate your class, your activity or fragment with this e-fragment annotation. And doing so would instruct the Android Annotations compiler to create a generated subclass of your class, which kind of has all the boilerplate written for you. So every time you'd rebuild, then a new generated file would be created, and it would just have all this boilerplate for you. So it supports the same features as Butterknife. You have the find view by ID guy there, and here you have the click listener. But it also exposed some even more powerful annotations, like a background annotation, which means that particular method would be run on a background thread. And another one is the UI thread. So, certain code would have to be run on the UI thread. And as you can probably guess, this was really, really easy to abuse and kind of led to some spaghetti code because it allowed you to write asynchronous code without really having a standard asynchronous model. Nobody likes async tasks anymore, but at least they had a standard template, and anytime you wanted to write an async task. You know there's 3 methods. I don't even know what they are anymore because I haven't written one in a couple of years. So yeah, the downside here is that by having your generated activity or fragment be the fragment that shows up in your activity, it's like you're not actually even writing your own code, and you kind of give up control of your activity or fragment's lifecycle. So you can't even use like the onCreate method in a class here because the views would not be bound yet at that time. And it just basically led to some pretty difficult maintenance issues. But that's all I want to say about Android annotations. Last guy I want to talk about is robo-binding, which of course is probably the most similar to the data binding solution that Google has come up with now. As you can see, the syntax is actually very similar to what we've looked at before. So in the XML, we have a bound of value. It basically says we're going to reference a variable called hello in our backing class. And then you can also have like on-click listeners defined in the XML. And of course, you can actually do this with stock Android. And I don't recommend using the Android on-click attribute because that would, by default, just call a method in your activity or fragment. It's totally inflexible, and it doesn't work with large applications, only like sample applications. So in order to use robo-binding, you would create a class called a presentation model that would kind of power the data binding. And so this presentation model is kind of a rigid structure, and you have to conform to certain rules. But I mean, generally, it was really innovative because it paved the way for data binding on Android. But unfortunately, it didn't really take off because there were a lot of limitations in the XML layout system and the Android platform that the developers of robo-binding had no means to change. So it really just didn't pick up too much steam. And there's also, sorry, I'm skipping over that. There's actually a lot of other frameworks that I mentioned earlier, like WPF, AngularJS, Knockout.js, and Adobe Flex, which is now Apache Flex, that have defined a bunch of data binding systems, and a lot of developers are familiar with them now, and there's a pretty good idea about what's good and what's bad in data binding. So there's pretty much a lot of foundation for Google to build upon. One downside that most of these guys that we have up on screen right now unfortunately encounter is performance. So the initial implementations, and since then they've changed, but they relied very heavily on reflection. So data binding quickly became synonymous with sluggish performance. And I want to segue that into how the initiative, like how did we get to the point where Google decided they're going to announce a data binding framework at I/O? Well, actually, it was originally slated for release with Lollipop, but that just kind of didn't work out because Lollipop grew much larger than anyone at Google had ever expected, and the devs that were assigned to the data binding project got thrown into other projects. So this year, towards the end of 2014, they were like, okay, what are we going to throw in Android M? So it was reconsidered. But unfortunately, it didn't pick up too much steam because there was kind of like this bad vibe around data binding. And just it's very polarizing. So it was kind of slow to pick up speed. But eventually, the developers passed around this design document, and it was passed around to like the platform team, Google's app developers, and the AngularJS team. And they got all these ideas about how they can implement a data binding solution that was super fast with performance and super powerful. And it required making some internal changes to the layout system. And also, they needed to get into the Android support library so it could be accessible to developers without an additional dependency. So once they finally got enough acceptance among the company, they're like, okay, well, let's go ahead and do it. Build a prototype. So these first prototypes were built in end of last year, and people are like, wow, this is fast, this is cool, let's do it. So they shipped, and they announced RC0 at I/O 2015, and since then they've had RC1, and RC2 is going to be coming out in just a few days. And it's actually pretty much feature complete right now. There are no planned API changes, so if you're waiting for an official release before you start messing around with it, there's no need to. API is final. So I've been talking a lot about the history and different frameworks and the motivation, but I haven't actually talked about how you use data binding on Android. So I just want to cover that real quickly. So this is like the most basic layout you could ever imagine. It's just a text view in an empty XML file. So if we wanted to use data binding here, all we do is kind of push out that text view and wrap it in this new tag, which is just called a layout, all lowercase. And also bump up that the XML namespace declaration to the top level, of course. So doing this actually tells the data binding compiler that you want it to create a binding for your activity. So wrapping it in the layout, there's actually no adverse side effects. It's completely backwards compatible. The only positive side effect is that you're going to get this new generated binding class created for you at runtime. Or not at runtime, but at compile time. In the layout tag, you can add this other new tag called data. And within the data tag, you can define variables and import classes. So here you can see I've declared this employee variable, and that would allow me to reference it later on in my activity. So if I were to just run this layout right now, it would look exactly like you would expect it to without data binding, because we haven't actually bound any data to it. So the text view would be completely empty. It would not crash. It would not complain. It would just show up as an empty text view. So another quick thing about the data tag I mentioned briefly is that you can import classes. So in this case, I'm importing view because I want to access the view.gone and view.visible constants. And down here, this is something a little new. Rather than accessing a property of our data model directly, I have a brief expression. So I'm saying if the employee was fired, I don't want to show that employee anymore. So basically, this is a ternary expression very similar to what you'd see in Java. And you can see it's kind of like in that @ squiggly braces wrapper, which basically means that the contents of that is going to be an expression. So word of warning, I'll say this now and I'll repeat it again later. Do not use complex expressions in data binding. It's the worst thing you can do. You will hate yourself. Don't do it. Anything more complicated than a basic ternary expression is too much. And that's the rule that I'm laying out here right now. So if you ever break that rule, I will be upset. And I will be sad for you. Don't do it. So I do want to talk about some of the things you can do with the expression language, even though you probably shouldn't. It really supports almost everything that you can do in Java. Without code completion, static checks, and it also has kind of confusing compiler warnings. So here's what you can do. I'm not going to read them all off, but it's pretty much everything you can do in Java. So it's not all bad, though. The expression language has some great features, the best one being null safety. So for example, if I were to hit my API and get a location object back, as you can see, it's like a JSON object with a location key, and then within that I have latitude and longitude. If I wanted to access the latitude in Java code, I would have to do something like this. And if you don't do it, your app will crash and you'll have a bad time. So it's painful, and especially if you have very deeply nested objects, your null checks can just get out of hand. With the expression language, that's no longer necessary. Basically, the way it works is that if you have an object like response.location.latitude, and any of the objects along the way is null, rather than crashing or throwing a null pointer exception, it will return the default value for the field that you were trying to bind. So in this case, latitude is a string. It would just place a null in the text view. And if, for example, latitude were a double or a float or whatever, then it would put 0 because the default value for a double is 0. So this can really clean up a lot of boilerplate for you. So at a first glance, I would say that it seems like magic, and everybody knows that magic is bad. But the good news is it's not magic at all, because all of this binding is made possible through generated classes. So the data binding support library is powered by a Gradle plugin, and that plugin generates these bindings for you whenever you have that layout tag as the root. And then once you get the bindings generated, you actually need to obtain an instance of them. And the easiest way to do that is with this inflate method. So rather than using like your traditional layout inflator to inflate a view, with data binding, you're going to use these generated binding classes. They have a static method called inflate. And notice that you don't need to like specify the layout ID anymore because that's baked into the generated class. So for my file called activitymain.xml, I'm going to use that activityMain binding class, call the inflate method, and then I'll get an instance of the binding. And then I can use the binding to set variables like employee or whatever else type of variables that you want to use. A second way to do it is to inflate your views the standard way with the layout inflator, and then call the bind method afterwards. But I would definitely avoid that because if the view hierarchy of the view changes between inflation and binding, it's not going to work, probably crash. So unless you have a really special need to do that, stay away from it. So all of these binding classes that are generated inherit from the same base class. It's called view data binding. And this allows you to do some really cool stuff with generics. So whenever you create a recycler view instance, you need to write a view holder for it. And right in this slide, I've just kind of written an example of a view holder that uses generics, so you can reuse it for every single class. You'll never need to create another view holder again. Basically, it says, I have this type parameter which extends from the view data binding, so it could be activity main binding, and then create an instance of it in my onCreate view holder method, and then in my onBind view holder method, I just get the binding and bind the variables. And logically, it just makes a lot of sense. I mean, you're binding in your onBind view holder and you're using data binding. It's like we finally have the tools to do logically what makes sense, rather than all these hacky methods one by one, like, oh, in my bind method, I'm going to set the value of this text view to this value. It's just so much better this way. So I said this once before, and I'm going to repeat it again. Avoid complex expressions in your XML layouts. They will get you every time. So there's limited code completion, formatting, static checks on expressions. In fact, a lot of the time right now, because the IDE integration is really not caught up with the library itself, they'll just show up as red, like invalid in the XML layout. So you want to avoid that. And if you do need to do something more complicated in data binding, use something called a view model. A view model is basically just something that adapts your data model to the way that it should be presented on the screen. There's a lot of theory behind the MVVM architecture. I'm not going to get too much into that, but basically I'm just going to say don't use complex expressions. Instead, use an object that represents a view model and then map the data that way. So a quick example that we just threw into Timehop, we added these notification screen, and we have these strings that are formatted where the name is bold and then the text or the action associated with it is not. So rather than trying to write an expression that would format that for us, we just created a view model with this method called formatted text, which does all this string concatenation and applying spans for us. So that's just kind of the basic idea of how a view model class would work. So far we've really only looked at some of the most boring XML attributes, like setting the text or setting the visibility. What if we wanted to bind something more interesting? Like for this checkbox, if we wanted to have a check change listener, define an XML. Well, rather than defining like some sort of custom binding adapter for every single property on a view, the data binder actually tries to set the properties automatically based on the XML attribute names. So since this attribute is called onCheckChangeListener, it's going to look for a class, or look for a method on this class checkbox called setOnCheckChangeListener, which conveniently exists. By setting the onCheckChangeListener in the XML attribute, we're automatically binding our model's property to the class's checkChangeListener. So let's take a quick look at that. Take a quick look at that method on our view model here. And it's very verbose because it's basically a method that returns a new checkChangeListener. The good news is, for your view model classes or objects that you use for data binding, it doesn't matter if it's a method or a field that you define as long as the naming matches. So, and what's more than that, it's actually very intelligent. If you're binding to a view property that has it's an interface, so say for example, checkChangeListener is an interface, and that interface only has one method, it's intelligent enough to say, well, we don't need that whole anonymous class, we can just bind it directly to that method. So this looks a lot like what you'll see in Butterknife or Android annotations. You just have a method that corresponds to a checkChangeListener directly in your view model. So yeah, if you don't want the verbose syntax, then don't use it. If you prefer to be more explicit, by all means do so. So all the bindings that we've looked at so far have been one-way bindings, pretty much. So if the data model that powered the binding was updated, we would have to manually sync the binding with the new updated model to invalidate it. So a more interesting use case for data binding involves like when you have a real-time relationship between the model and the view. So this is made possible through observable bindings, which are a feature built into the data binding framework. So a quick example of that. This is like basically a form with two edit text and then a big text view below it. And as I'm typing my name into the edit text, it's automatically formatting it below in real time. So it's kind of powerful, and it's especially cool because the activity that powers this is 2 lines of code. So here's the XML layout that I'm using here. As you can see, I'm starting out with the layout tag and the data tag as well with the person class in there. And the type of person is observable person. So here we've got these text change listeners added in XML. And these, of course, are going to map to properties on my view model. And then below, you can see I have the formatted name, which is another property that's going to correspond to something on my view model. I will show you that right now. So this is my observable person class. And one thing to note is that it extends base observable. Base observable is a class that exposes property change notifiers. So basically, the UI can update automatically. So basically, I have these two text watchers, and I'm saying that after either the first name or the last name changes, then I'm going to set this private field on my model, and then I'm going to notify the framework that that property has changed. So you may look at this and say, well, hey, what is br.formatted name? That's weird. I don't like that. You probably also said the same thing when you started working with Android, and you saw things like r.string.hello. It's the exact same thing. So whenever the compiler does a rebuild and generates these bindings, it creates constants for these fields, so you can notify them that they get changed. So admittedly, this is a little complex. That's okay, though, because it makes our activity look like that. So we've removed all of the code from the activity. And just a reminder of what we're doing here again, this is just the demo one more time. So 2 lines in an activity gives us something as powerful as this, which I think is pretty cool. But if you don't want to worry about like property change notifiers or implementing base observable, you don't have to either, because the data binding framework gives you something a little bit simpler called observable fields. And these guys are self-contained fields that support observability. So there's an implementation for every single type that you can imagine. And a cool part about them is that they're serializable and parsable. So if you use them for tracing your UI state for tracking your UI state across configuration changes, the UI will reflect that state automatically, which can be really awesome. So another demo I've got here. This is, I don't have the layout file or the activity for it because I figured you guys can put 2 and 2 together for now. But this view model has one observable Boolean called isAnimating, and then it has a click listener, and both of those would be bound in XML. So in the click listener, I'm setting the observable Boolean to true, and then I'm performing an animation, and then once the animation is complete, I'm setting that to false, and I just want to show you what that looks like. Yeah? Pretty cool. So what's powerful about this is that rather than keeping track of your state in your activity and then always constantly keeping the UI in sync with the state of the activity, you have a variable called isAnimating, which is the single source of truth for whether or not that button is enabled and whether or not that animation is running. So one other cool thing here, I said that you don't really need to use IDs for your views anymore, but if you choose to do so, you can access the views directly from the binding. So the image that's animating across is called binding.letMeExplainYouDataBinding. So simply by having an ID for that field, I can access it in code without calling findViewById. And another really cool thing about this that I didn't put in the slide is that the data mining framework allows you to update the UI regardless of what thread you're on. So you don't ever have to worry about running on UI thread again. So pretty great. So as we've seen, the vast majority of data, like text, click listeners, check change listeners, enabled state, those can be set using the automatic setters that kind of just look for a matching property on the view. There are some cases where you can't do that, though, because there either is not a method in Java that corresponds to the XML attribute, or you want to do something completely new and different. So one quick example is like the padding left property. If you've ever set padding left in XML, you know it's just a single attribute, and it's great. But if you have to set it in code, you have to actually set top, left, bottom, right, all at the same time. So binding adapters are a tool that are in the framework that kind of help you resolve these issues. So I want to start by showing you the padding left binding adapter, and this one's actually built in for you. Pretty much every view attribute that you'd ever need is already built for you, so the only time you're going to be writing custom attributes is in special circumstances. But basically what we've got here is a binding adapter annotated method with the attribute in the argument, and then it's a public static method that basically just kind of is called whenever you use that XML attribute. So another quick example that I want to show you of these guys here is if you wanted to like load an image with Picasso, for example. We have the binding adapter annotated method, and then a method with two parameters, first one being an image view and the second one being a URI. So by declaring the first parameter as an image view, you're creating a contract that says this binding adapter will only work on types that inherit from image view. So obviously you can't load an image into a text view. Well, you can set a drawable, but that's another story. Okay. So yeah, and in some situations, you are going to need to have more than one method parameter in your binding class. So here's another example where we're setting both an image URI and a placeholder. And basically that's saying that this binding adapter will be used if both of those XML attributes are set. If only one was set, then the previous example would be used. So basically the framework is going to find the binding adapter that has the most matching attributes and then use that method to bind the data. So there you go. One really important detail that I've talked about briefly throughout the presentation, but haven't gone into too much detail, is performance. So the majority of data binding frameworks before this, actually more like the ones created through the mid-2000s, relied heavily on reflection and were super slow. So just in case you still have concerns that this is going to be slow and adversely affect your performance, I just want to ease those for you. So first and foremost, Android's data binding implementation has no reflection at all. It's all using generated code. And this is a very popular model now, like Dagger 2 is completely generated code based. And that was actually one of the big differences between Dagger 1 and Dagger 2, is that Dagger 2 is completely generated code based and it's much faster. Secondly, the code in these generated classes is highly optimized and much more efficient than code that you'd write by hand a lot of the time. I talked about how finding a view by ID is expensive and it requires a traversal for each view. I'm not going to mention that again, but data binding only requires one traversal to bind all of the views. Also, the changes for the UI, they're batched together. So, for example, if you had a callback where you were updating the state of 10 different UIs, you'd have 10 different views, you'd have to update them each one by one. So data binding batches them all together and runs them on the UI thread for you. Some more advanced math and bit flags are used to track the state of the invalidation of views, so it's not going to be redrawing and rebinding the data if nothing has changed. An additional cool thing is that the values inside of expressions are cached. Now, I told you not to use complex expressions, and I'm only mentioning this because I feel like I should. But so, for example, I have two expressions down here, and in the middle of them, they have a ternary expression, B. If B, then C or D, whatever. So if I use that in two different expressions, the value is cached. It's only evaluated once. So it's pretty powerful in terms of performance. So that's pretty much all of the new stuff that I wanted to talk to you about data binding for. But just to kind of give you my conclusions, or our conclusions at Timehop about data binding, there's a lot of great things and a lot of not so great things. On the plus side, it removes UI from your activities and fragments, built into the support library. The performance rivals some of the best handwritten code. The declarative XML layouts are the single source of truth for your UI. The API is complete and the release is imminent, and you never need to worry about the main thread for updating the UI again. Downside, ID integration is abysmal. There's really no refactoring support, there's really no code completion, and sometimes, like if you switch branches, the generated code classes need to be rebuilt, so you might have issues building until you clean. So overall, I mean, it's a very polarizing issue, as I mentioned. I think it's got a bad rap because of poor performance from other frameworks, and it's easy to abuse if you start writing complex expressions in your XML. So I think the general advice that I'm going to give you is use data binding in places where it's appropriate to use. Don't use it where it doesn't make sense, and don't write complex expressions in your XML. And I think you can find that it really makes your code a lot cleaner. So that's pretty much all I have. So after the thunderous applause dies down, I'll be happy to take any questions. Like, do you mean if you want to bind, Yeah. Oh, okay. Yeah. Well, I mean, you can definitely use IDs if you want to. I'm just saying that you don't need to use IDs to bind the data. But yeah, you'll definitely need IDs and relative layouts if you want to, position things relative to each other. About what? Oh, yes. So he asked about testing. So testing is a bit challenging with data binding. Roboelectric actually does a pretty good job because you can actually test the generated view bindings. You probably don't want to write unit tests for generated code, but then again, you shouldn't have to because the developers of data binding, they have their own suite of unit tests, so you can assume that it works according to the documentation. So Roboelectric is pretty good. You can do UI tests with that, believe it or not. And also Espresso is good. But yeah, you're not really going to be able to have too many unit tests for the actual binding itself. If you follow me on Twitter, I will tweet the link to the slides. So he asked about binding like list view or grid view data with data binding. In general, it's not supported out of the box, and I think that's kind of a good thing because if you'd ever worked with like Windows Forms or Microsoft data binding solutions, I feel like there isn't much value. Personally, this is just an opinion, but by all means, you can write a custom binding adapter that would allow you to pretty much do anything like binding a grid view or list view adapter or anything like that. He asked about unbinding, and that's something that I haven't really thought about too much. So I don't know. The generated binding class, the inflate method or the bind method, will return an instance of the view data binding subclass. So you can hang on to that reference. And it's also obviously associated with, like the view is associated with the UI. And any reference that you maintain to the binding class will be yours to keep control of. And then if for some reason you lose that reference, if you call the bind method, it will return the existing binding method. But the layout itself is just scope with whatever screen it's on. Yes, we are using it in production. The first thing we used it for was our onboarding screens. And for new features, we're kind of experimenting with different ways of playing around with it. We just recently added the generic view binder into some part of our app, and it just seems like a really great way to just cut down on the boilerplate. So yeah, I mean, it's not in all parts of our app, and I wouldn't recommend that you dive head first into data binding. Just use it somewhere, side project, one screen. It's really great on simpler screens. You were scarred by what? Oh, WPF.